Hi everyone, this is Sree Ganesan and I'm head of software products at Habana Labs. I'm here to talk to you about how you can train more and spend less with Habana Gaudi using the EC2 DL1 instances. So today in this talk, I'll give you a little overview of the hardware and software architecture. We'll talk about how to set up DL1 and a little bit about the use cases where you can actually take advantage of Gaudi's benefits. So it's no surprise that there is an explosive demand for deep learning training. There are a lot of businesses that are taking advantage of AI for a lot of their applications, and they're building a lot of complex models. And a recent IDC study indicated that about 74% of the respondents were running a lot of iterations of training, up to 5 or 10 iterations, and then 50% of them are building models weekly, and another 26% of them are actually rebuilding daily or hourly. So clearly there's a huge demand for training cycles. And here today we're going to talk about the cost to train, right? The biggest barrier that's reported is cost. It's one of the most significant challenges that businesses have in terms of implementing AI solutions. And as an industry, this is a challenge for us. How do we provide our end customers and users access to more affordable AI training? This is where Habana Gaudi comes in. Gaudi is a purpose-built AI training accelerator built by Habana with the sole purpose of accelerating and improving training efficiency for deep learning neural networks. It's built from the ground up specifically for this purpose. And it's different from the general purpose and GPUs and CPUs. It has a heterogeneous compute architecture, and it has a GEM engine for accelerating your matrix math operations. It has a cluster of TPCs or tensor processing cores, which are used for accelerating the nonlinear and element-wise operations in your neural network. It has a software-managed memory architecture and 32 gigabytes of HBM2 memory. And this 32 gig HBM allows you to actually port models easily from the GPU or to Gaudi because it's a similar training regime you will be using. Lastly, but more importantly, this is one of the industry's first AI processors to natively integrate 10 ports of 100 gigabit Ethernet, RoCE ports, on the device. And what this allows the training to take advantage of is the scaling. So for training, you need a lot of the ability to train beyond a single device. You need to scale to multiple devices. Distributed training is actually very important. And having these integrated RoCE ports does a significant performance improvement in terms of scaling capacity. We get near linear scaling. You get the flexibility from having these industry standard devices because you're not reliant on a proprietary interface. You can use standard Ethernet protocols for scaling up across devices within your server and across nodes, multiple servers. It's the same protocols. And there's cost efficiency because you're not using discrete NICs. These are integrated NICs, and this allows us to save power and cost. And all of these cost savings are returned back to you, the end customer and the end user. And you'll also notice the picture on the right is the Gaudi card. It is also an industry standard OCP OAM form factor. So you can see that we are big proponents of actually industry standard protocols and interfaces. So there's all this goodness in terms of the training efficiency and capability that the hardware provides, but without a compelling software stack that accompanies it, you can't take advantage of it. So here's where Synapse AI Habana's software suite comes in. It's been designed for both performance and getting the best out of Gaudi and ease of use because you want to be able to take advantage of the hardware without having to sweat over the software. It's integrated with both TensorFlow and PyTorch. There is a framework integration layer that takes your computation graph from the framework and extracts the subgraph that needs to be accelerated on the Gaudi devices. Synapse AI does a lot of the work under the hood. So it'll basically use the graph compiler and the communication libraries to actually take the subgraph and then build out the performance optimized recipe to execute on the Gaudi devices. We have a very rich performance optimized kernel library that the Habana team supplies as part of the software suite. And in addition, we offer for customers who want to be able to write their own kernels, a TPC programming toolkit with which you can actually write these custom kernels and register your custom kernel library with Synapse AI. So you are taking advantage of both Habana's library and your own custom library to actually get the best performance out of the hardware. We offer a suite of tools for debugging, profiling, so that you can find bottlenecks in terms of performance. You can identify how, where the problems are and continue to optimize for performance. And we haven't stopped with this. A couple of slides later, I'll talk to you about how we are actually making it easy for end users and developers to take advantage of all this goodness with the software stack using our developer site and GitHub resources. So one of the most common questions is, okay, great, how do I get started with Gaudi? So we have designed it with the end user in mind and making it easy for end users to get started. So this is a very simple example on the left that shows an example of a neural network that's using the MNIST data set. And you see 2 lines of code highlighted over there. That is to load the Habana module and then invoke it. And that's all that's needed to get you started with training on Gaudi. You don't need to make any more code changes. What this does is it registers the Habana libraries and the Habana device. Habana device is, Gaudi is called the HPU, or Habana Processing Unit, in the framework. And once this library is loaded, TensorFlow will recognize that now you can start running your workload on the Habana HPU device. And there's a set of operators that Habana supports already on Gaudi. So if your operator can run on Gaudi, it will be assigned to the HPU, so it's prioritized on the HPU. And if it doesn't run on Gaudi, basically falls back and runs on the CPU. So either way, basically your model will start working immediately with the portions that you can accelerate on Gaudi landing on that device, and the rest of it falling back to the CPU. And that's all it takes to get started with Gaudi. So I wanted to mention about our developer site and that we're all in on usability, because it's not enough to have a great piece of hardware and a compelling software stack. We need to make it accessible. We need to make it easy for developers to use it and take advantage of all the goodness that this device offers. And we have put a lot of effort in the recent past to actually build out a suite of resources. There's a wealth of information available for developers to get started easily. Our developer.habana.ai is sort of the hub for developers. We have a lot of resources in terms of documentation. We have how-to guides. We have simple tutorials. We have a lot of examples. Most interesting is our GitHub repository. We actually publish open source content where you can actually go in and find over 30 plus optimized TensorFlow and PyTorch models, which are very popular and already ported over and working on Gaudi devices. So you can go in there, download these, and get started with training on Gaudi right away. There are also very simple nuggets of simple tutorials where you can understand how to start writing your own models and porting your own models. We have video tutorials, and we have a Habana catalog, which makes it easy for you to go find the content that you need. And last but not least, on the developer side, we have the Habana Forum. We want to encourage developers and end users to come in and have a vibrant community on our developer site. So this forum is where we encourage folks to ask questions, engage with the Habana experts as well as the broader Habana community. And we want to build out this even further going forward. Okay, so all this goodness, how do I get started, right? Where do I get my hands on a Gaudi? So Gaudi is available on EC2, the DL1 24x large training instances. You can get started right away. It has an excellent price performance, up to 40% better price performance than training with leading GPU-based instances. It's 60% on-demand price, 60% lesser than the P4D instance price. It has 8 GPU Gaudi processors, and you'll see the details on the bottom line about the various other components that are part of that DL1 instance. You can get started with just the vanilla EC2 instance. It's integrated with ECS and EKS for those who want to run containerized applications, AWS Batch. We have deep learning armies and deep learning containers available. There's also base armies available on the marketplace. So there's a lot of material available, and in the forms that users have consumed it in EC2, and it's very easy to get going with the Gaudi-based DL1 instances. So what is the value proposition in terms of both the price performance that we talk about? So let me first talk about the training performance. I will use two models, ResNet 50 as a proxy for vision models and BERT Large as a proxy for language models. So you'll see here for vision models, compared to ResNet 50 compared to V100 and A100, both for single card and for 8 cards. We land somewhere between a V100 and A100, and basically the performance-wise, you don't lose a significant amount of performance compared to these other instances. And for NLP, this is for BERT Large. I've got two charts here. One is showing phase 1 and phase 2. They are two different training regimes for BERT. And so the performance is slightly different on each. And for phase 1, you see that it's again somewhere between V100 and A100. Phase 2, we start getting much better, much closer to the A100 performance. And when you translate this performance in terms of the cost savings to the end users and customers is where it gets really exciting, right? So for ResNet 50, we offer up to 60% better cost savings than V100 and 46% better compared to an A100. Similarly for BERT Large, 54% and 31% for phase 1, 75% to 57% on phase 2. So overall, you'll see that you get a really compelling cost savings if you switch to a DL1 instead of another instance. So now we'll talk about the kind of use cases, because this is something people are interested in hearing about. What does Gaudi support in terms of the use cases? How can I take advantage of all of this cost savings? How can I train more and spend less and apply this to the business problems that I have? Some of these are examples of use cases that we have customers exploring Gaudi for. While I can't talk publicly about specific, I can tell you about what topics they're using it for and the use cases they're applying it for. We have obviously 2D and 3D medical imaging use cases where it's actually accelerating outcomes, patient outcomes in the healthcare space. We have use cases in the retail space where they're accelerating inventory management and checkout with Gaudi. We have obviously in the autonomous space, 2D and 3D object detection as part of mobility solutions. A variety of use cases for the NLP space as well, where we're using it for question answering, subject matter query, sentiment analysis, and so on. So in the next few slides, I will basically start talking a little bit about specific use cases where we are able to share a little more in terms of the cost advantages that Gaudi provides. So first is accelerating healthcare workloads with Habana Gaudi. I'm going to talk to you about a customer that we are working with, Leidos, who's using Gaudi in terms of exploring Gaudi for various healthcare applications. They work with the FDA, NIH, CDC, and a variety of other government agencies, and are trying to explore cases of using Gaudi's cost savings to apply in specific use cases where there's a cloud forward strategy with AWS and DL1. So I'm going to talk about, I can share more about the specific use case, which is a proof of concept we conducted. It's around basically first proving the cost effectiveness of Gaudi in this specific use case. Second is understanding how this offering can be incorporated as part of a customer's cloud forward strategy. And then other use cases in terms of saying, are there ways to take pre-trained models and make them available for customers to easily take advantage of these and offer them as a service? So these are the various aspects that Leidos has been exploring with DL1. So in this example, we actually are showing you for this proof of concept. This is very contextual. There's been a huge kind of focus on healthcare R&D and trying to accelerate discovery, diagnosis, and treatment in the context of COVID. This example, this use case is about how you can detect COVID from frontal chest X-rays. So this is pneumonia that comes as an outcome of having caught COVID. So there were two models that we looked at. One is basically a pre-training with the ChexNet model, which actually detects and identifies various diseases from basic chest X-rays. And then the second is then fine-tuning using a COVID ChexNet model, which allows you to then take that model and then detect COVID pneumonia in these frontal chest X-rays. So we used publicly available data sets, and Leidos did these experiments with the NIH data set for the pre-training, and then the COVID data set. There are published papers that they've reproduced the results with, and this is the POC that we conducted. So in terms of the cost savings, this is the most exciting part, is that they were able to demonstrate, they compared it against P100, they were able to demonstrate significant cost savings for both the pre-training part as well as the fine-tuning part. The pre-training part is 59% and 67% cost savings with fine-tuning. So you can see actually the specific numbers in terms of the cost for the instance, the time per epoch, and actually the cost to train, and how we calculated the results in terms of the cost savings from switching to DL1. So in summary, Leidos concluded that using EC2 DL1 actually for these chest X-ray based COVID detection use cases for both pre-training and fine-tuning is a significant cost savings, which they could then go recommend to their end customers. They were able to successfully train these models with very minimal code changes, and they were very happy with the kind of support they found on our developer side and in terms of the reference models that were available. So it's something that they were able to take advantage of and complete the POC successfully. The second one is a use case in NLP, where actually the Leidos team used DL1 with an NLP use case to actually accelerate application processing. So this is for a customer that is taking advantage of deep learning solutions to facilitate medical benefit application processing. So in this case, we actually, again, the similar objective, can we take EC2 DL1 and demonstrate the cost performance advantage? The customer is using a GPU G4DN 12x large instance. How do we show that there is a cost benefit to the customer in terms of moving to DL1? In this case, the example is a TensorFlow Distilbert model, which was fine-tuned for a multi-label classification task and trained with 737K labeled images, tested with 184K examples. At the bottom of that, you see the table that shows the description of the two different instances, just as a baseline in terms of the memory accelerators available, the kind of accelerator, and the cost. You'll notice that obviously the G4DN has a much lesser cost compared to the DL1 instance, but since this is what the customer is using, they wanted to compare the performance and see if there was cost savings that they could still offer with DL1. So as the outcome of this study and the POC, basically, they were able to compare the performance of Gaudi-based DL1 versus the G4DN. And what they were able to show is, again, a very significant cost savings with DL1 because they were able to train in a much lesser time. And you can see both in terms of the time to train and the cost, they're able to reap advantages. And so they're taking advantage of the architecture and the capabilities of DL1 and running it on 8 Gaudi devices. From a user experience perspective, they found it very easy to run on a single card with very intuitive changes. And they reported that it was especially distributed training and turning it on with Horovod and MPI was actually fairly straightforward for them to go from a single card to an 8-card instance and be able to reproduce and get these results. So this is super exciting that, even though it's a very different and old instance, they're still able to take advantage of DL1 and show the cost savings for their end users and end customers. So in summary, this latest team actually concluded that from an architecture perspective, Gaudi performs significantly better than even an NVIDIA T4. And they basically looked at both cost and time as a metric. And they believe that DL1 is worthy of strong consideration for a cloud-forward strategy for their customers using deep learning models. And for those customers who are cost sensitive, this is a very attractive option. A couple of areas where they're looking into future work with us is basically the fact that it's a lower cost. They had picked a TF Distilbert model because it was a smaller model that they could use. They're now looking at exploring more complex models because now they can take advantage of the power of DL1. And the other part is actually doing domain adaptation with DL1 for pre-training these models, because then there's a lot of context that comes in with domain-specific text, and then they can start doing a lot more with these NLP-based models, which are more domain-specific with pre-training. So it's pretty exciting that they're going to be looking at some of these as well and taking advantage of Gaudi for DL1. Overall, in summary, this quote, kind of gives you the theme behind what Leidos is after. Basically, they are looking to service their customers' need for quick, easy, and low-cost training for deep learning models, and they're looking forward to collaborating with us. For me personally, this is actually exciting given the backdrop of this pandemic, and for like the last few years, there's been an explosion in the kind of focus on healthcare, and being able to see the technology that we're working on actually touch lives and actually make an impact in terms of positive outcomes for society is actually really, really exciting, and I hope we can do more with the healthcare customers going forward with DL1. I'm going to switch to a completely different space, which is fintech, where we actually have another very interesting use case that I wanted to talk about. So here's an interesting startup that's trying to look at servicing the corporate financial trading market with real-time valuations and risk derivatives. And this is calculated throughout the day, and they want to start figuring out how to accelerate their solutions. So their current problem is that they have to compute results using a very slow, noisy simulation method. It takes a very long time, very compute intensive, and it doesn't allow them this very fast turnaround. So their solution has been to take the simulation models, use the data from the simulation, and then basically turn it into deep neural network and based approaches to kind of use AI to then accelerate the outcome for their end customers. So they're using synthetic data sets and then kind of getting these solutions implemented by training them and offering them as fast inference capabilities. So the interesting thing is, for them with these types of calculations, they have exotic architectures. These are not, the typical neural network architectures that they typically use, and they have exotic derivatives that they have to calculate. And their problem is that they have non-standard layers that are not necessarily optimized, and things get to slow down a significant amount. And so they were interested in exploring if does Gaudi offer me a chance to do something different and better than what I have today? Can I accelerate or do more training for less cost if there's a possibility to accelerate this outcome? So they actually evaluated Gaudi, and they were able to use the Gaudi instances to actually get started with their TensorFlow model. They reported that it was super easy to get up and running with the TensorFlow model. They actually used the Synapse AI profiler that I talked about. They wanted to profile where the bottlenecks in their code because they had these unique challenges with their code base and wanted to see if they had ways to use a profiler to visualize the bottlenecks. And they're very happy to use our profiler and identify some of the bottlenecks. In terms of performance, they were actually using ResNet-inspired architectures, and they actually were surprised to see that these ran as fast as feed-forward networks on Gaudi. And they were basically trying to use them for areas where they believe there were slower training opportunities and see if they could explore with Gaudi. And that's some of the next steps that they're going to pursue because Gaudi opens the door for them to solve problems that they didn't have a chance to solve before. So they're eager to continue these experiments and build it out from here. So in terms of their experience, basically, they are confident that they'll lower the training cost and improve the model quality, and that would translate into tools for their end user. And the interesting thing about this whole use case in the FSI space is that they were using ResNet-inspired architectures to go solve some mathematical number crunching problem, which is not something that we've typically associated with this domain. And this is a very unique way of solving problems. And they found a unique architecture and a solution with Gaudi. And we're looking forward to finding more such partners who can kind of break the paradigm. And what does it's basically what does a new architecture, a new platform, a new software stack allow you to do that you didn't think could be done before? And this is an example of what's possible. So with that, those are the two examples and two use cases where customers are actually taking advantage of cost savings with Gaudi and looking forward to doing more. I hope it gives you a view into the world of what's possible with Gaudi, and that it'll encourage you to start your journey with Gaudi and DL1. Encourage you to take advantage. Take a look at our website, our developer site. Definitely check out the Amazon EC2 DL1 instances, and you can post questions on the Habana forum. We are happy to serve you and partner with you. And if there are any questions, anything else that you'd like to learn about, I'm all yours. Thank you.